happy National Chemistry Week as well. We are so thrilled you are joining us tonight. My name is Erin Mayer. I am a lead teacher with Beyond Benign, and I am joined this evening by a team of lead teachers who will be assisting in various capacities behind the scenes, helping things run as smoothly as possible. We are so excited tonight to feature a newly released book, Green Chemistry and Sustainable Science, a green approach to sustainable STEM in K-12. To get our evening started, we'd love to learn a little bit about you. Please introduce yourself in the chat by sharing your name, location, and the grade level you represent. Please make sure that the name we see on your screen is the name that you would like to have printed on your certificate of attendance for this evening. This is how Beyond Benign gets names to create those certificates and send them to you. Additionally, if you are comfortable doing so, we welcome and encourage you to share your video feed because it does foster a more intimate and engaging experience for everybody. We do understand, of course, that there are occasions when that's not possible, and we are certainly understanding of that. If you haven't done so already, please join us on social media by following us at Beyond Benign at all these various social media platforms. We are always excited when we see posts sharing not only our content being used, but also the innovative ideas created by our followers, as well as inspiring stories within the green chemistry community. I would also like to remind everyone that by registering for the webinar series, you have agreed to our code of conduct. We are essentially asking for participants to be kind, accepting, and open to varying viewpoints and opinions. This series is being recorded, as you saw earlier. While it is expected that our video feed will focus on our presenters, your voice and video feed could appear at some point. So by attending this discussion, you give your consent to allow us to post video and sound of you. As we launch into tonight's webinar, I'd also like to pause for a land acknowledgement. I'd like to acknowledge the unceded land on which Beyond Benign operates. Beyond Benign is located in the state of Massachusetts, which has been the traditional land of the Pawtucket and the Massachusetts nations. We acknowledge the history of this land and encourage others to acknowledge the unceded lands and territories belonging to Indigenous nations across the world and wherever you are tuning in from tonight. We would also like to give thanks to our sponsors who make this series possible for us. Beyond Benign is an organization working to foster a green chemistry community that empowers educators to transform chemistry education for a sustainable future. It is our vision to ensure the chemical building blocks of products used every day are healthy and safe for humans and the environment. And we believe education is the most powerful and critical component to achieving this. This is why we are committed to pioneering a paradigm shift across the continuum of science education, from K-12 through out-of-school programs, undergraduate, graduate school, and into industry. The reality is there is a demand for green chemistry skills, and we don't currently have the workforce equipped to solve sustainability problems using chemistry. We are excited to feature presenters in our Observe, Wonder, Think series who are working to change this. Just a few days ago, on October 10th, the Green Chemistry Teaching and Learning Community launched. This joint initiative between Beyond Benign and the ACS Green Chemistry Institute, with support from the sponsors you see on the screen, is a space for all of us to share, connect, learn, and grow. The GCTLC hosts a central online searchable library of green chemistry education resources, including but not limited to lab experiments, lecture materials, and in-class activities. The hub allows users to create profiles, connect and network together, share ideas and resources, collaborate and give and receive feedback, as well as mentorship. As I mentioned before, we are so excited tonight to feature a newly released book in our conversation. Again, it is titled Green Chemistry and Sustainable Science, a green approach to sustainable STEM in K-12, and it is available for download on the GCTLC. This guidebook was created by members of the New York Green Chemistry PLT and Beyond Benign lead teachers. The goal of the book is to support new and veteran educators to use green chemistry principles as they engage all students in learning experiences through sustainable and safe means. By sharing New York standard aligned activities, lessons, and a larger We have provided some practical examples of how to integrate green chemistry into instruction and to promote active student learning of chemistry concepts. We have included examples from elementary, middle, and high school to both show a progression of student experiences and to demonstrate the practical implementation of green chemistry principles at any grade level, elementary, middle, or high school. While we call this book the New York edition, aligning these activities to New York standards, these lessons can be utilized across the country as they can also be aligned to next generation science standards and other state standards. Tonight, we will be highlighting activities from 2 chapters in the book. Beyond Benign certified lead teacher, Annette Sebuyira will get us started tonight by sharing a middle school activity titled The Particle Nature of Matter. I will, after Annette shares her lesson, will be sharing a lesson from chapter 4 titled What Happens When We Combine Substances, a Greener Approach. This is an upper elementary lesson that can also easily be adapted for middle school level. This year, every one of our Observe, Wonder, Think webinar series will always be highlighting one or more of the 12 principles of green chemistry that you see on the screen. Tonight's activities will focus specifically on green chemistry principles number 1, 3, and 12. So before we dive into our first presenter, I want to take a moment to briefly review those principles. So principle 1 states, it is better to prevent waste than to treat or clean up waste after it has been created. This principle is often referred to as the prevention principle. The other 11 principles are the how-tos to achieve principle number 1. Principle number 3 focuses on less hazardous chemical synthesis. Wherever practical, synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. Simply stated, the chemicals and materials used in affecting chemical transformations matter, and we need to pay attention to the choices we make about what goes into the flask. And finally, our third focus green principle for this evening is principle number 12, safer chemistry for accident prevention. According to the American Chemistry Society, safety can be defined as the control of recognized hazards to achieve an acceptable level of risk. Green chemistry principle number 12 is known as the safety principle. This principle is the logical outcome of many other principles. In fact, it is practically impossible to achieve the goals of principle 12 without the implementation of at least one of the others. Eliminating exposure before it can occur should always be the level of safety that we are reaching for. So without further ado, I would like to introduce our first presenter. Beyond Benign certified lead teacher, Annette Sebuyira. Annette is a New York State Master Teacher Emeritus, a National Board Certified Teacher, an adjunct professor for Syracuse University, and a certified Beyond Benign lead teacher. Annette earned a master's degree in science education and taught science at Guilderland School District for 31 years. During her tenure with Guilderland High School, Annette taught AP Chemistry, Supa Chemistry and Supa Forensics, and Regents and Honors Chemistry. In 2013, Annette attended a workshop that was presented by Beyond Benign through a grant by DEC at Siena College, and that forever changed her life. She has been passionate about green chemistry ever since and has not only implemented the green chemistry principles in all of her teaching, but is also a co-facilitator of the New York State Green Chemistry Professional Learning Team that meets monthly in a virtual space. After her retirement in June of 2022, Annette continues to be a consultant with the Beyond Benign organization. This past summer, Annette, along with other lead teachers, co-authored the cross-curricular lab book that we are going to feature tonight. You can find more examples of Annette's contributions on the new Green Chemistry platform, the Green Chemistry Teaching and Learning Community. As a final reminder before we get started, our goal tonight is to engage in an interactive session. So please, if you have any questions during the presentation, type them in the chat. It is my pleasure to turn the dialogue over to Annette.
Thank you so much, Erin. That was good work. And thank you for what you do for our OWT to be able to be on this platform. And happy Chemistry Week, everyone. So the activity I'm going to share with you today deals with particle nature of matter. This is a middle school lab. And when I was thinking about how to get students engaged with this middle school lab, I wanted to take into consideration what's been going on around us. Most of you know that this past summer, we were all dealing with the fog and smog that came from the wildfires. We also know that we had heavy rains, and we also know that we had a severe winter. So putting all those things together, I wanted a lesson that students could relate to. And so here we go. So the focus question on this particle nature of matter is, what atoms make up fog, rain, snow, or sleet? And Erin's going to help me play the video. So we begin the phenomena by watching a video that is weather related. And this is from our local weather channel. So of course there will be advertisements in the background, but what I want kids to look at is to see that there's fog in here. I want them to notice that there's rain. And I also want, that's I think a game or something, that's an ad, but I want them to notice what rain appears like if it's a heavy rain, what the snowfall appears like, and if it's a heavy rain. And if Erin, you can just skip the ad, we'll take to it. So you can see that there's sleet, there's snow, and there's rain, and these are dangerous driving conditions. As you all remember, this past winter, every time you turned on the news, there was some pileup on some highway that was caused by the severe winter conditions. So that's a good one, actually. I can pause right there. Pause it and we can go back to the presentation. Yeah. Thanks, Erin. All right. So what okay. So what I want kids to see, this is weird. I'm not doing anything. Is that me? Ah, thanks. Okay, so what we should notice is that when students think about snow, when they think about sleet, when they think about freezing rain, and when they think about rain itself, in their thoughts within themselves, I don't think that they're thinking about it as a chemical. I don't think they're thinking in depth of the particle arrangements. I don't think that they're thinking on the molecular level. So what I wanted to show to the students is to take them back to what the definition of chemistry is. And of course, the definition of chemistry is the study of matter and the changes it undergoes. And I put pictures on there so that they can see what snow looks like. Hopefully, I'm getting responses such as, oh, you know, snow is light and it doesn't hurt, but sleet or hail, if it falls on you, it will hurt you. It's a thicker solid. Rain, if it's heavy, you can't walk through it. I'm looking for all that. And usually fog, students always go back to the word mist. But then I also want them to see that little animation on the bottom right, that you can see that all those molecules are identical and they're moving around and they're changing. They can be close together, far apart, and really far distance. And in there, we start our discussion of having a solid, that this is all water, that whether we call it fog, rain, snow, or sleet, on a molecular level, it is a chemical known as water with a chemical formula H2O, one oxygen, two hydrogens. And so that's what I'm trying to get them to think, that it's not different things happening in there, but it's the same chemical with a different arrangement. And once the arrangement changes, you can see that if they're close together, you have a solid. When they move apart, you have a liquid where it gives you mobility. And when they're far apart, you have a gas. So then we can take our fog, rain, snow, sleet, and refine our responses by talking about the particle arrangement and by symbolically, chemically representing it either as H2O solid, H2O liquid, H2O gas. So on this particular slide, the main objective was that the student is able to use particulate models to reason about observed differences between a solid, liquid, phases and among solid and liquid materials. So we were using the weather phenomena for that. So in the activity itself, we begin by doing the background. My students at this level know that atoms are the building blocks of matter and that each element is made of the same kind of atom, and that if different atoms come together, you formed what's called a compound. So the pictures are a good visual for the students to see that, oh, okay, I don't just throw two spheres together to get something, but you can see if the uniform color in there will represent the identical atom, and then you change them. And then you can also see that these atoms can combine in many, many different ways. So it can be as simple as a molecule of oxygen, or a 3-atom molecule such as water or carbon dioxide, to a more complex 3 different elements, but more complex, such as in ethanol or ethylene glycol, which you can also tie back to our winter lesson, because now we talk about antifreeze. You know, when the car is freezing, what do you put in the engine? And more complex ones, you know, such as aspirin, because you do get a headache from that bad weather. So I also want the students to know that there are different ways of representing chemicals. So on this particular slide, it's a visual of saying you can use molecular models, which is going to be the activity that they take on. You can use symbols, and then you can also write chemical formulas, so that this time we explain what the subscript means, so that the students know that, okay, so water has 2 hydrogens and an oxygen. And I explained that in science, we try to make everything brief by gathering similar elements together and giving them a subscript, so that you do not write the formula for water as HHO. You just use a subscript of 2. So this particular lab is geared for the middle school, and there are 2 performance expectations. 1-1, develop models to describe the atomic composition of simple molecules and extended structures. And I put visuals of different chemicals which are simpler. And the focus for this one, because we're trying to be safe and not have hazardous material in the lab, we're going to use molecular models to represent something such as methanol, which is flammable, and also ammonia, which is an irritant once inhaled. In the middle school, they don't usually have fume hoods. So instead of you bringing in the actual chemical and exposing your students on that, you have them constructed by using the molecular models. So the second performance expectation is the 1-5, develop and use models to describe how the total number of atoms does not change in a chemical reaction, and thus mass is conserved. So you work with the students to show them that the number of atoms that you have at the beginning are exactly the same number of atoms. They may combine differently in a chemical reaction, but when you add up the total masses, it's the same. And when you add up the total atoms, it's exactly the same, which is the law of conservation of mass. So this is what the lab looks like. To the left, on part 1, they begin by making simple molecules, and you can see that a teacher has to sign off. So they're using colored pencils to draw what they have made. So it's make it, draw it, get a signature. So in the first part, they do simple diatomic molecules, and you can use that term at the middle school, or you could just say 2 of the same elements combined together, depending on your choice and the level of where your students are. After we've gone through that, we then decide to change them around, and now you're combining different elements to make one compound. So now we're talking about binary compounds. So you can see that the ammonia and the water are there. And I like that I use the common names, because then they can relate to, these are things that they've seen in their homes. Part 3 now has them testing the law of conservation of mass, the law of conservation of matter, where they take the symbol and quantity of the first atom, and then the symbol and quantity of the second atom. And so, for example, with water, as you saw before, there's there's a hydrogen and a hydrogen, there's the two of them. And then the second atom is oxygen. So you started off with a total of 3. When you write the formula quantity, you still have 3 different atoms or elements combined in there. So that's the second part of the lab. The questions that are geared to this, we discussed the limitation of a model. Hopefully you're explaining to them that in real life, they're not as well aligned as they are, and they're not as large, because a model is just a representation. We can talk about also the limitation of just drawing on paper, where you have a 2-dimensional as opposed to a 3-dimensional. And then we can also talk about, in the second question, you can see that we're now asking them to talk about the main ingredient in isopropyl, in a hand sanitizer, which is isopropyl alcohol. And I give the formula, and then I want them to use their response and color coding as they had done before to make that. And part 3 of the third question will be, from your activity, make a statement that relates the total number of atoms before the reaction, and I apologize, this is cut off, before combining and after combining, and that's guiding them towards the law of conservation of mass. So every single lab should have a hazards chart so that students are addressing the hazards associated with the chemical that they've studied or used in this lab. So question 4 goes, in this activity, we only use models to represent these chemicals. Explain using the green chemistry principles why this is a greener activity. And hopefully you're saying that we were not exposed to the hazardous or inhalation hazards that might have been part of the risk of using the actual chemicals. And this template's actually from a really good friend of mine, Ann Klotz, who's here tonight, but I use this for every single lab so that every time the students are working with something or learning about something, they address this. So we don't do it just at the beginning of the year, you do it the entire year. So these are the anticipated outcomes. On the right is what the first part 1 and part 2 would look like. And on the left, this is what the part 3 of the lab would look like, whereby they're addressing the law of conservation of mass. And this particular one, these are actually those, I think they're not foam, but they're like a sponge ball, and you buy them at Halloween, and there's a whole bunch of them, and the kids just stick them right onto their lab. They do it like a poster form. So it's just a good visual for them to see that, okay, if I have a color chart like this one, I'm starting off with 6 different things in water, 6 atoms total, and I have 6 atoms total on the other one. But those are moles of atoms, which you can then also explain. And the second part of the lab, as I insisted, is that always evaluate the hazards. So the chart on the right is the key. So the challenge is that look at the hazard rating for methanol. What do you notice? Based on what you noticed about the hazard rating for methanol, what will you do to stay safe while using this substance during the activity? So even though they didn't actually come in contact with it or be exposed to it, it's important to know what if they came in contact with it. And this idea comes from, you all remember in Palestine, Ohio, the train that derailed, whereby, there were symbols, but the residents, all I kept on seeing on the news where the residents were saying, where they're telling us that we are safe, but I've heard something else, we are not safe. And in actuality, I think it was hydrochloric acid that was going into the atmosphere. So just by even having kids learn this in school, they can help their families to sort of tell them more about this. And you can see that the hazards of methanol have the fire sign, which they can look up. It tells them that that's flammable. the skull and crossbones, it's poisonous. And of course, it's dangerous for your health, where you see the human body being shattered. I use Sigma Aldrich. There are many, many other resources that you can use in there. But this one, the poster is in the room and it's easier to use. So I use this one here. And as Erin indicated, we try to address and let you know what the connection to the green chemistry principles are. So this is principle number 3, less hazardous chemical synthesis. Use the students who use chemical hazard rating system to evaluate the toxicity and hazards associated with the substances whose models that they have just been using in the investigation. And so again, this particular lab, the particle nature of matter, used principle 1, principle 3, and principle 12. Okay. Right back to you, Erin. Thank you so much.
All right. Thank you so much, Annette. That was awesome. Thanks for sharing the particle nature of matter activity, which again is from that Green Chemistry and Sustainable Science book on the GCTLC. I do want to, again, just share, let's see. So waste prevention in the activity that Annette just shared, we're using models in place of actual substances, less hazardous chemical synthesis. Of course, the kids are evaluating the toxicity and hazards associated with the substances that they were modeling in the investigation. And finally, the safer chemistry for accident prevention. So we are avoiding hazards by using models in place of actual substances. Okay, so next up, I'm going to go ahead and share a activity from the book. This is an elementary focused activity, but actually can be very easily converted to middle school and potentially even high school as well. My name again is Erin Mayer, and I am a middle school science teacher. I've had the amazing privilege of working alongside middle school scientist explorers for over 20 years, and I currently teach at Casey Middle School, which is in Boulder, Colorado. So the lesson that I'm going to focus on is titled "What Happens When We Combine Substances?" And the focus question, what the kids are trying to figure out as they work through the activities involved in this lesson, is how can we use green chemistry practices to determine if mixing 2 or more substances results in a new substance. The connection to the next generation science standards is on the screen here. So this is specifically connected to Physical Science 1-4. Disciplinary core ideas, we are touching on chemical reactions. As far as the science and engineering practices, the focus is on both analyzing and interpreting data and obtaining, evaluating, and communicating information. And finally, the cross-cutting concepts that are integrated throughout the series of activities that are in this lesson are cause and effect, and scale, proportion, and quantity specifically. So students will begin the lesson by experiencing the phenomena. In order to prevent waste, so this is a connection back to green chemistry principle number 1, the phenomena is going to be demonstrated by the teacher in order to reduce waste. So I'm going to ask you for the next few minutes to put on a student hat and engage with this phenomenon. I'm going to play a short video of the phenomenon. And as you watch the video, I'm going to ask that you record your observations, your wonders, and your thinks in the Jamboard that Chloe just posted in the chat. I will play the video first. It's about 2 minutes. There's no sound in it. And then I'll give you about a minute to add any ideas to the Jamboard. And I will kind of highlight the ideas that are being added as we go. All right. And butterfly pea or cabbage juice can be used as an indicator. I chose the butterfly pea tea just because I'm very partial to all the beautiful colors it creates. All right, so if we want to take a moment and just use the sticky note feature on the Jamboard and just pop in some observations that you have, any questions that you have, or any asyncs or inferences that you have. And this is something that I do with students for any time that we encounter a phenomenon. Is really just have them focus on what do they see, what questions does this bring up for them, and what do they think might be going on. So give everybody a few seconds to do that. So we have some good questions. So why did the butterfly tea turn purple? Is it magic? I mean, I can actually imagine like a fifth grade student wondering, if there is magic. Did the temperature change? So some noticing that afterwards, it looks like there's some bubbles and some new colors. We've got some white solids, a heterogeneous mixture. When the calcium chloride and sodium bicarbonate are mixed, it looks powdery, looks like one substance, white solid again. All right, so this activity, thank you so much too for participating in that Jamboard. This activity is just to get them thinking and get them excited about what we're about to move into as we move through the lesson. So let's see, I can get to my next slide. Next, what I have the students do is we go ahead and do some evaluation of hazards. So we look at the hazard rating for all of the substances involved, and they will decide what they need to do to stay safe while using any substances. I have found that this is a really good way to make kids just aware before they go into any investigative setting where they are dealing with substances. It empowers them to make really good choices. And again, the connection here is the principle number 3, less hazardous chemical synthesis. So again, they're going to evaluate the hazards of calcium chloride, sodium bicarbonate, and we will let them know that red cabbage juice or butterfly pea tea, whatever you decide to use, is used as that indicator. So I'm actually going to have everybody back on the Jamboard for a moment. I'm going to have you put that student hat on again. And on the second page of the Jamboard, so if you look at the top, we're on page 1, the observe, wonder, think. If you go to the second page, just take a look at the calcium chloride hazard rating and go ahead and from a student perspective, again, upper elementary school or middle school, what might you notice? What do you notice? And then based on what you notice, what will you do to stay safe while using this substance during the activity? And again, I'll give you another few seconds or a minute or so, actually, probably to add your ideas to that Jamboard. Again, page 2. So some of the things that are popping up here, not flammable, so we don't have to worry about catching on fire. Definitely not going to taste it if it's bad for my health, given that rating of 2. It's unhealthy, but not, it could be worse, I guess, is one of those. Oh, we need some PPE, so we need to be thoughtful about wearing gloves and safety glasses and things like that. And aprons, washing hands after interacting with any substances. And again, this is just a great way to empower kids to make really safe choices, because they're the ones doing the evaluating prior to walking into any of these activities. All right, so awesome. Thank you again for your participation. I'm going to go ahead and move to our next part of this lesson. And I should say too, this is like a multi-day lesson. So this is not something that's happening in one class period. So for part 3 of the activity, which is called Combining Substances Investigation, the kids are going to participate in a micro-scale investigation to determine which combination of substances are responsible for the changes that they were seeing in the phenomenon itself. So conducting this investigation at that micro scale certainly connects back to principle number 1, waste prevention. So we are using very small amounts of substances, and we are reducing waste in the process. I generally have, we spend some time talking about differences between qualitative and quantitative observations. So they are, in this particular investigation, they are measuring temperature, and they are also doing qualitative observations, so things that they can use their senses to collect data about. So they make a prediction prior to combining substances, and then once they combine the substances, they do some initial data collection and then some after combination collection, and then they have to decide, do they think something new forms or not? And they have to support that claim with evidence. All right, and then finally, the last portion of this lesson is really getting back to the idea of communicating, understanding, and arguing in science using evidence. So they are going to write a claim evidence reasoning statement. So in that claim evidence reasoning statement, they are choosing a claim. Again, we're talking about younger kids right now, so I tend to, at least as they're learning this idea of claim evidence reasoning, I like to give them 2 alternative claims to choose from. Certainly, you could just scale this up by just asking them to create a claim that's an answer to the investigative question. So based on the trends, do they think a new substance is being formed when they combine 2 things, or do they want to claim that a new substance did not form when they combine 2 things? So notice there's not really a right claim to this. I think they could go with either claim. It just really depends on what their evidence and their reasoning is to support that. So once they decide which claim they're going to focus on, once they decide what substance or what things they're going to focus on with combinations, they're going to go ahead and provide 2 specific pieces of evidence from the investigation that supports that claim choice. And again, there's some sentence stems that are provided there for them. Okay, so upper elementary, easily middle school as well. And the focus principles in this particular lesson were waste prevention and less hazardous chemical synthesis. So with waste prevention, the phenomenon was demonstrated by the teacher. So we're not going to have as much waste going on with not only substances, but with things like plastic bags as well. And the second focus on waste prevention was completing the combining substances investigation on a micro scale. Less hazardous chemical synthesis, the students are evaluating toxicity and hazards, okay, and empowered to act accordingly. And the second sort of focus for less hazardous chemical synthesis is that we are using red cabbage juice and or butterfly PT as our indicator solution. Two things, red cabbage juice, obviously readily available at the grocery store, and butterfly PT is easily available from Amazon, and one bag of it will last you for years. So that's going to be less hazardous chemical synthesis. Okay. So what we'd like to do for a couple minutes now is have you think about an upcoming investigation or a learning activity that you are planning on having your kids engage with. And how might you and your students intentionally integrate either Green Chemistry Principle 1, Waste Prevention 3, Less Hazardous Chemical Synthesis, or Chemistry Principle number 12, Safer Chemistry for Accident Prevention. And what I'd invite you to do is just to take a moment to consider an upcoming investigation and then respond to this question in either the chat, or feel free to turn on your microphone and share it with our group. I would suggest that it would be helpful to provide some context about the grade level that you teach, and what particular unit or focus area this activity might be geared towards. I'll go ahead and give everybody a moment. Oh, and there's a question. So they get solutions of the compounds when they're doing the microscale investigation. And we do talk a little bit about what a solution is and why we're using the solutions. So thank you, Anne, for that clarifying question.
So, Erin, actually, I've just noticed that most of the members were not with us before, so they haven't heard about you. So, as they're thinking, I want to tell them a little bit about you.
Oh.
So, Erin Maya has the amazing privilege of facilitating the learning of scientist explorers at Casey Middle School in Boulder, Colorado. She has been working alongside young learners for over 20 years to create safe and open learning environments filled with opportunities for learners to lead their own learning as they connect with and develop deep and enduring understandings of the natural world. She challenges her student learners to be inspired learners who think critically, ask questions, and design solutions. She encourages learners to think big and broadly, discovering and cultivating their strengths, talents, curiosities, and ideas as they address local, national, and global issues, ultimately empowering them to take action and make our world a better place. And that's greater evidence in what she has just shared.
Thank you, Annette. So thanks, Audrey. So using natural food colors for acid-base balance lesson. I'd love to, if you could kind of maybe in the chat, just talk about what kind of natural food colors are you using? And again, if it's the end of a long day, which it probably is for everybody here, it's late. If you're not coming up with anything that's immediately connected to waste prevention, less hazardous chemical synthesis, or safer chemistry that you're going to be investigating in your classroom, you can also feel free, if you're thinking about what are some things that you might have heard tonight that might just be easy ways to integrate more green chemistry thinking into your own pedagogy or your own just general classroom practices. That'd be a wonderful thing to add to the chat too. Thank you, Teresa. So teaching 7th grade students how to build a wet cell battery, reducing waste generated by reusing the electrolyte solution between classes and reusing the electrodes. And then using, again, thinking about less hazardous materials to use. Awesome. Appreciate that, your contribution there, Teresa. Okay. So hopefully these activities have given you some food for thought. And again, they are located in the green chemistry book that Chloe shared with us. So, whoops, I went a little bit too fast on myself. Before we sign off for the evening, I want to invite everyone to join us for our next Observe, Wonder, Think. That will be occurring on November 16th at 6 o'clock Eastern Time. And we will focus, actually, we will have two more of our amazing Beyond Benign lead teachers sharing some other lessons from the green chemistry book. So Stephanie Loomis and Veronica, Morabito Weeks are going to be sharing some high school lesson and an elementary school lesson. Also, if you're planning on attending the 2023 Stanny's Conference, which is coming up here on November 3rd, so just a couple weeks, please plan on attending the Inspiring Students with Sustainable STEM and Green Chemistry, which is presented by some lead teachers that are here on the call with us tonight, Stephanie Loomis and Scott Carlson. And of course, always feel free. We encourage you to join in the dialogue on any social media platforms that you belong to. Annette, did you want to talk really quickly about Eastern Standard?
Absolutely. So last week on Friday the 13th, in preparation for National Chemistry Week, Steph Loomis, who's here tonight, and myself had the pleasure of presenting at the Eastern Stannis, and we were able to meet Billy Green, who is the recent recipient of Educator of the Year, and we did the Halloween theme. The theme was scary, so we did a murder mystery storyline to do a density lab and a lemonade, which guided folks into being able to rewrite the green chemistry principles. It was a lot of fun, and it was at Schenectady Community College. So hopefully you guys will join Scott and Stephanie for more fun in the next coming month.
Thanks, Annette. And then finally, on the third Wednesday of each month, Beyond Benign is offering another interactive webinar series, which is featuring community leaders and active practitioners in the field. They are having small group discussions, resource sharing, and networking opportunities with both industry leaders and higher ed community. Participants bring their own resources and share them out to the community during these sessions. The meeting time is 12 to 2 p.m., so obviously not ideal for many K-12 teachers for obvious reasons. However, if it's something that is interesting to you, please register for the webinar, and then you will have access to the recording after the webinar happens, just like you do with our Observe, Wonder, Think webinars. And you might also think about sharing the opportunity with any other educators or administrators that do not have tight classroom schedules to increase their understanding of green chemistry. If you haven't already done so, please scan this QR code on the screen to sign up for our newsletter to stay up to date, and also to get more information on the GCTLC, the Green Chemistry Teaching and Learning Community. And finally, just again, thank you so much to Annette, and thank you for participants for sharing your time tonight and for sharing your ideas and your thoughts on the chat and the Jamboard. We so very, very much appreciate it. We look forward to seeing everyone at our next Observe, Wonder, Think in November. Good night and take care.